To understand the modern enterprise, we have to look back at how automation began. During the Industrial Revolution, physical machines were built to handle manual, repetitive labor in factories, drastically increasing production capacity. Decades later, that mechanical workload shifted to data. By the time early digital mainframes arrived, automation meant offloading basic calculations and record-keeping to software. But this created a new bottleneck. Today, many large organizations rely on dozens of disconnected legacy systems that simply cannot communicate with one another. The result is thousands of employees acting as human bridges, trapped in endless loops of swivel chair data entry, copying information from one screen and pasting it into another. This is the exact problem Robotic Process Automation, or RPA, was designed to solve. Despite the name, RPA has nothing to do with physical robots. It is a strictly digital, non-intrusive software layer. To see how this software layer enables wide-scale digital integration, we have to look under the hood and deconstruct a fully functional enterprise pipeline. This diagram represents a modern loan processing architecture. Approving a loan requires pulling customer data, checking credit scores, validating documents, and assessing risk across distinct computing systems. Notice how data flows from customer submission down to quick loan approval. The bank can automate this entire sequence without ripping out and replacing their existing multi-million-dollar IT infrastructure. By deconstructing this exact workflow, we can isolate the mechanical constraints of RPA, examine how it operates precisely at the user interface layer, and see how engineers design the necessary handoffs between deterministic code and human cognition. Looking closely at this specific node, data extraction and validation, we find the critical bottleneck. Incoming customer applications must be read and entered into the bank's internal mainframe. Traditional business process automation approaches this by attempting to wire systems together from the inside out. This requires engineers to write complex integration code and build custom APIs directly at the database level, a slow, expensive process. RPA bypasses the backend entirely. Instead, software bots operate directly on top of existing applications, mimicking human actions like clicking, typing, and navigating across the glass, the graphical user interface. Operating at the surface layer delivers immediate strategic advantages. Because the underlying architecture remains untouched, implementation is incredibly fast, and there is zero risk of breaking the legacy systems below. It also enables elastic scalability. If loan applications spike during a busy quarter, the bank can instantly spin up additional virtual bots to handle the volume and spin them back down when demand drops. Furthermore, these bots can operate 24 hours a day, 7 days a week, without breaks. As they work, RPA systems automatically maintain detailed, continuous logs of every single UI interaction. For highly regulated industries like finance, this guarantees absolute auditability and strict compliance with data protocols. RPA provides a strategic method for bridging isolated legacy systems through human-like digital behavior, sidestepping the need for costly system-wide overhauls. However, this UI-level approach has strict mechanical limits. Moving down the workflow from data extraction, we hit a node labeled exception handling. RPA bots are entirely deterministic. They execute strictly defined, rule-based sequences. They possess zero cognitive flexibility to handle the unexpected. This creates a direct vulnerability known as UI dependency. Because the bot is programmed to interact with specific visual elements on a screen, a minor software update or a relocated submit button can completely break the workflow. There is also the risk of process dependency. If an existing manual workflow is poorly designed or highly inefficient, deploying an RPA bot will simply execute that exact same inefficiency at a much faster rate. Even if the interface is stable, input variables can trigger failures. When a bot encounters unstructured data, like a highly ambiguous email or a handwritten note on a scanned document, it cannot interpret the context. It forces an exception and immediately halts. To mitigate this, enterprise pipelines employ a human-in-the-loop architecture. When the deterministic bot hits an anomaly, the system seamlessly pauses the workflow and flags a human worker to review the ambiguous data and resolve the issue. True automation design is not an attempt to eliminate human workers. It is the careful engineering of these exact failure points, ensuring that rigid, rule-based bots cleanly hand off complex variables to cognitive human judgment. The heavy, independent data processing we just looked at is known as unattended automation. These bots run completely in the background, executing high-volume batch tasks continuously without requiring any human intervention. But not all processes can run in the dark. In customer-facing environments where high-touch human interaction is mandatory, organizations deploy attended or desktop automation. Consider a live customer service call center. The process begins when a human agent answers the phone and opens their local customer management system. The agent clicks a trigger button on their screen, instantly waking up an attended RPA bot. The bot simultaneously queries the isolated CRM, billing, and legacy systems, aggregating the required transaction histories into a unified view, eliminating manual search time. The bot can then take an active role. As the human agent maintains a natural conversation with the customer, the bot prompts the agent with real-time suggestions and executes complex data entry tasks in the background based on the agent's commands. Within this call center environment, the bot functions as a real-time digital exoskeleton, directly augmenting the human's operational capacity. These architectural rules apply across all major sectors. This flowchart diagrams an RPA implementation for medical billing in the healthcare industry. Notice the nodes for patient registration and coding and billing compliance. These are high-volume, highly repetitive tasks that are exceptionally prone to costly human errors, making them ideal targets for automation. Building standalone bots in isolation leads to broken workflows. A governed ecosystem is required. Before coding, organizations must initiate process mining to standardize business rules. You cannot automate a workflow until the underlying logic is stable. Once the technical logic is set, companies face the strategic challenge of change management. Employees frequently resist adopting new technology due to concerns over job security. To govern adoption, enterprises establish a centralized Center of Excellence, or COE. This COE acts as the core authority, supervising all RPA development. They ensure every bot adheres to strict security protocols and complies with industry regulations. The reality of enterprise automation is that success is rarely defined by the software alone. A robust RPA deployment is typically 80% process standardization and change management, and only 20% actual bot programming. To fully grasp RPA's position in the modern tech stack, we have to distinguish it from older tools. A common misconception is that RPA is just a rebranded version of traditional macro-based scripting, like VBA in Excel. The defining difference is scope. A macro is permanently locked inside a single host application. It cannot easily pull data from a web portal into a local spreadsheet. RPA operates across the entire operating system interface, seamlessly connecting entirely different software suites. It also vastly outpaces traditional coding in terms of flexibility. Modern RPA platforms rely on low-code or no-code visual workflows, allowing business analysts and non-programmers to quickly modify automation logic as departmental needs change. When we zoom out and look at the enterprise, the architectural value becomes clear. RPA functions as a non-intrusive integration layer, mapping data across isolated systems without requiring high-risk alterations to the underlying IT foundation. It creates a bifurcated workforce. Unattended bots relentlessly execute high-volume, deterministic batch tasks in the background, while attended bots deploy at the desktop level to elevate speed and accuracy for human workers. Successful digital transformation requires precise human architecture, mapping the workflows and standardizing the logic necessary to facilitate a seamless handoff between rigid digital bots and cognitive human workers.